So hi, my name is Nabil. So I'm a solutions engineer as well as Alain at GitHub. So I'd first, before diving right into the presentation and into the demo, I'd like to present first briefly what I do at GitHub, is Github Actions, and then we'll dive into like a demo. So basically, as a solutions engineer, I technically assist on the sales side on the South EMEA region. And what we sell is Github Enterprise. Has anyone of you heard of Github Enterprise or used Github Enterprise? I know you do. Do you? Okay, perfect. So basically, it's the enterprise offering of GitHub. So it comes as GitHub Enterprise Cloud and GitHub Enterprise Server. I'll be very brief on that one. But basically, GitHub Enterprise Server is like GitHub.com, the same UI packaged as a VM and VM on-prem. And there is GitHub Enterprise Cloud, and GitHub Enterprise Cloud is basically the private space of the company on GitHub.com, and they can manage their code with organizations and repositories, as you know. And then you can connect and unify the administration with GitHub Connect, so have a unified search across GitHub Enterprise Cloud and GitHub Enterprise Server. And yeah, because when a client buys GitHub Enterprise, they have access to both GitHub Enterprise Cloud and GitHub Enterprise Server. Enough about the sales speech. So let's dive into GitHub Actions. So since the acquisition from Microsoft, basically GitHub has been, but first, GitHub Actions was designed and thought as a way to automate GitHub. So for example, whenever I have an issue, I want to have automatically generate a comment or something like this. Or when I have a pull request which is open based on the file which is changed on the pull request, I want to have a special label. For example, it touched like a file in src/main, for example, and I want to have like a main label. And we have a lot of actions which have been written into that space. But then from the community, we had a lot of traction and asking for this to become like a CI/CD platform. And this is when so how is it? So I want to just emphasize first how is it different and what is like the value proposition of GitHub Actions and why would you use GitHub Actions instead of like something else, basically. So first off, it's fully integrated with GitHub, so it works on the cloud. You don't have to manage any infrastructure. And then the second thing is it can respond to any GitHub event. So the GitHub events are issues or deployments, and you have a lot of them, and you can look at the documentation. I'm not going to list them all. The community-powered workflows is the most important to me, because what GitHub is doing here is like bringing basically the community, which you can reuse GitHub Actions. So for example, we have open source actions from HashiCorp, like writing about Terraform, for example. So you can just reuse this action, and since an action is like a function, you have input and output, so you can just supply the right input and give you then the output by using this open source one. And that's a big change. Instead of like just copy-pasting from another repository the file and then just modifying and tweaking some values, you can just reuse, and it's clean and tidy, and it's managed for you. So the code of the action, you don't have to maintain it, and you can choose which version. We'll see that, but which version of the action you want to use, not reusing something that someone else has done. Any platform, any language, and any cloud. So it's very agnostic, as GitHub being a platform and open. So is GitHub Actions. So that's it. So now I'm going to dive into a demo that I'm gonna present. So basically, the presentation about the demo. So what I want to say is like it's an incremental demo. So it's done step by step. So I'm going to present first the steps. So this is about first all the open source actions that you can find on the marketplace. And for example, there's a huge reuse them. As I was what I was saying was like this demo is incremental, and these are the steps that we are going to follow. So first, we're going to see how to build like very basic workflow, and we are going to take the opportunity about this to talk about what is the workflow, what's the definition of a workflow, what's the definition of a step, and how to define a workflow. This kind of thing, really setting the ground to understand how does GitHub Action work. Then we want to see how to build like on different operating systems, so OS X, Linux, and Windows, and how easy it is with GitHub Action to do that. Then to see how to save artifacts. So for example, when you build, you do some testing, you have some, for example, logs, but it's not like an artifact that you want to deploy to production, but it's an intermediate artifact that you still want to analyze. So how can you pull it from this pipeline without like SCP to the build farm or finding the proxy and these kind of things. And then how to push to GPR. So just an example of pushing like an artifact to GitHub package registry, which is the equivalent, like it's a binary storage like Artifactory or Nexus repo. And then how to cache dependencies to make our build faster. So not going to Maven Central every time, but like caching it locally. And if the pom.xml doesn't change, we just fetch the one which we already downloaded from the internet. Yeah, so let's dive right in. So I'm just gonna sit. So let's look at first about how to create just a basic workflow. So here is the diff that we prepared for that. So what we can see here is that we created one file, which is a YAML file, and here we can see that we have a .github/workflow/branch-build.yaml, and this is the convention to define a workflow. Is like a workflow is one YAML file under this folder. So you can have several workflows in one repository, and which will be executed after a trigger. So on any event of GitHub, it will listen to this event and then trigger the series of steps that you described. So let's dissect a bit this diff. So here we have the name of the workflow in order to find it more on the execution panel that we'll see just after that. Then here we have the on, so which defines the trigger, basically on which event should I trigger this. So here we decided to trigger it on push. So whenever I have a push on a branch which is not master, so I want to branch ignore master, I want to trigger, and within its job, the steps are run in sequence. So here I have only one job, which is this job build, but I could have several of them. So then a job is composed of a name, which is same thing to find it on the execution panel that we'll see. Then we have the runs on. So runs on is the VM that you choose to run on your pipeline. So here we decided to choose the Ubuntu 18.04 VM. You can use macOS and Windows. We'll see that in the next step. So once we've set that, we can define these steps, and these steps are run in sequence. And if one fails, basically, the other will not run. So what I want to do is like first set up JDK 1.8, and here here the uses is the action that it uses. And here what we can see is like if we go to github.com/actions, you will see like this setup-java action which has been written for us, and we're just reusing it. And as I was saying in the introduction, I am choosing the version v1, so I could choose like version 1.1.3, for example. And as I was saying, like an action is like a function, takes inputs and gives outputs. And the with here enables us to really supply the input into the action. So here with java-version 1.8, so I'm just supplying Java version 1.8 so that it can just set it up. So then the next step would be the checkout. So I'm just bringing the code from github.com into the VM where I'm executing this workflow. I'm using still an open source action, and then the step afterwards is just to test and package, and I'm running nvn packaged war. So I don't know if you have any question any question about this this workflow definition, which is pretty basic, and what is a workflow and so on and so forth. Okay, great. So now let's see how on the execution how does it look like basically. So this is the next tab. So here is how the Actions tab look like. Here we have basically the workflows. So for example, here we have build test, here the name that we find here, build test. So if I had several workflow, I would have a list of items here. And then if I do each workflow here, sorry, if I have each workflow here, build, test, and package, this is one step. Exactly. And then on this step, I have these jobs, and this is pretty familiar, like the dark background and what we have is basically live logging. Here it's already executed, but we have basically live logging, and we have the time it takes for every step. In time, what we did is we built our application. So here we check out the code. We can see that it's basically doing a git pull. Then here we did a test and package. So just MVN package. So it goes to Maven Central, fetches the dependencies, and then here's just complete job. Yeah. So can we dive into the next step now, or do you have any question about this step? Okay. Let's dive into the next step. So here, this is done. So building an application which needs to run on OS X and on Windows, and I want my pipeline to run on these three steps. So this is pretty easy with GitHub Actions with a feature which is called a matrix build. So here the diff seems pretty big, but basically what we added, what we changed, is this part here. So instead of like runs on hard-coded like Ubuntu 18.04, we're going to parameterize this and add a matrix.os, and then in the strategy here I will put a matrix with two different values. So what it will do, it will basically execute an Ubuntu 18.04 across all these versions of Java, and basically you'll just put the parameter here of matrix.java, and then there is as well matrix.os. Here it is, exactly. This strategy fail fast false is like if a step, it's just a custom thing. Like if a step fails, I don't want it to impact like others. But this is it. So pretty straightforward and pretty simple. I don't know if you have any questions about this. Nope. Okay. Awesome. Yeah, so here is so here is the execution. So this will be done the execution of every done in parallel, because it's like different jobs. Right. So so then what we can see here is like here is one execution with 1.7, and here an execution. I'm not going to do them all, but like Ubuntu 1.8. Let me do another one for macOS here, and then here is macOS 1.8. So it's pretty easy to do just the matrix build. Just wanted to show that. So if you don't have any other questions here, yep. Yep. Send it to package registry if you want. So you have like, since it executes it like in a VM, you can have a step to send it somewhere else, and you can just get this back. There is like we're going to see the next one with save artifact that you can use, and then you have a drop down, and you can just download it by clicking on the stuff.
Also, if you do a code release,
yep.
You can publish the artifacts on the release.
Yes, by using like the API, for example.
Yeah. Yep. You use Go Releaser, for example.
The what? Sorry.
Go Releaser is a project.
Okay.
Go project.
Okay.
You will automatically attach the produced binaries to the tag release.
Yeah, as long as they have a CLI, you can do basically whatever you want. Okay, so if you have the GitHub Actions, even better. Yeah, you can just use their action, absolutely, 100%. Yep. All right. Perfect. So that was it for the matrix build. And the question makes us just go smoothly into the next step. Thank you for that. It's the saving of artifacts. So basically here what we're going to do, it will be very straightforward. We'll just use small diff here. What we do is just that. So I'm saving the artifact by using the action upload artifact, and I give them the parameter of the name of how I want to save it. So matrix.os, matrix Java, and GitHub SHA. So this is provided by GitHub by default, the SHA, and then the path is a .folder. So the folder that I'm currently in, and this will have the effect to just creating a drop down here in the artifacts. So if we look at the previous one, we didn't have this. We didn't have this here artifact. And then just clicking on it, I just download it basically, and I can retrieve from the virtual machine from the pipeline into my my local machine. And since all the team will be using GitHub, you can just any member of the team can just download it pretty easily. So even for communication perspective, it's really nice. Pretty straightforward. I don't know if you have any questions here. Yeah.
The base image you're using for the operating system, for example, Ubuntu and macOS, is it the same that Docker file, for example, where you can customize that base image, or are they possible base images for virtual machines?
So the virtual machines, you can't customize it, but you can use your own container. So I don't have this in the demo, but what you can do is like supply your own image, your own Docker image, in which it will run. So instead of being a virtual machine, it will be a container based off an image that you design with your Docker file.
So you can provide the Docker file to GitHub and build your application.
Yes. Yes. Yep. Which gives you a lot more flexibility in terms of like control of what you want to have into your container.
You can work with any cloud you want, and you are attached to.
You're not attached to Azure by any means. So the thing is that here you have self-host. So this runs on GitHub servers. What you can have is like the self-hosted runners, where basically you just run a binary and on your own machine, and the execution will be done on your machine. So and then this runner, since it's a binary, it's pretty easy to download. You can put it on AWS, Azure, wherever you want, on your own VPS or wherever you want. Yeah?
So I guess that those runners is included in secrets in case that you want to push into external web packages like that.
So the secret management, there is a secret. I think we'll see that in the next step. Yeah, we will see that in the next step here when pushing to GPR. I'm just spoiling, but you can. I'll show you how. But you can have like a safe way of managing secrets at the repo level. Yeah.
You want to support more files about raw or something about more things that work. Yeah, different like that.
Yeah. Yes. Yeah, I don't see why you couldn't hear. Yeah. Yeah. In the what, sorry? Yep. So like here, basically.
Here, pretty much whatever you want, that's stored here. So if you are producing any other file to go here, you can set to support that. And the goal is really to be able to, whatever you are producing, something that's been created during the build, and you want to look at that after. So as Danny said earlier, typically use case is $, during for instance, or using like Selenium or some other like Cypress, for instance, where you do some video recording of your user testing. This could be uploaded as well. So whatever you want to look at after the build to double check what happened, you can upload that, and we're going to keep it for a healthy amount of days, and so you can look at that after. So just to define the path of the file that you're looking for?
Yeah, you just define the path, and as you using the action/upload artifact, so this is the parameter, that's it, and then it's uploaded.
Question, is there any limit in the file size you can load or the cryptation you can use from the GitHub service?
Yes, there's a limit. Next, just kidding. Yeah, I don't remember, but it's pretty high. It's like several gigabytes.
Okay. Following this question is like you have different deliverables. So this artifact you can have binaries registered as well of the build, Well,
you want, yeah.
I mean, if you want to push somewhere else, I don't know if we have an example of that where we use directly the command line.
For GPR?
No, for anything like the shell one.
Maybe.
I think we have, because you could always just run a shell command like scp, or ftp or whatever you want, and you can push.
You know what? I don't have it. I'll send it.
Oh, you mean if you have to go through the firewall and everything? I mean, either you whitelist our agent pools, because we can provide you the IP address, the IP ranges of our agent, and so you could configure your firewalls to trust these IPs, or you use your own agent that you're running locally in your infrastructure as well, or an action that can be used to upload to S3, and then you do that way as well if you want. But, I mean, there are plenty of options. It really depends on what your constraints are.
Any other question? No? All right. So yeah, we presented that. So that's the drop down to save the artifacts. Let's go. So then, yes. So the save artifacts is done. So let's look at how to push to GitHub package registry. So S3 or Nexus repo within GitHub binary storage, basically. So in order to push to GPR, so here is a lot of it's a lot of lines of code, but it's pretty easy. Basically, what we are doing here is building the Docker image, okay, in a new step. And I just wanted to show here that you can have a condition in order to skip a step, which can give you some more flexibility. So here, for example, I just wanna build Docker image if Ubuntu is 18.04, if the OS is Ubuntu 18.04 and the Java version is 1.8. Then, as we were saying, like just a shell. Yeah, it's just like shell commands, and here we can see that like Docker build, and this is the command you would use even locally to build a Docker a Docker file, basically. And then we have the push to package registry, which is what is interesting here. Still the condition. Here we can set environment variables, and we have the secret management here. So let's finish this and then go and look at how the secrets are managed. So here, in order to run what we do, we just log into docker.package.github.com, which is the package registry of GitHub. We just push the image, we push the GitHub_repository, and the name of the artifact is bookstore. And if we go to packages, so if I go here, I open just a new tab, I will go to packages here, and we'll just find it here, basically. So we have the binary which is pushed to the Docker package registry. Then something pretty important is the secret management, so that you avoid putting your secrets into files and leaking them, which is very important. So in an encrypted way here, if you go to settings on your repo, you will find it's an encrypted secret management. So here I have Azure credentials, GPR token, this is the one I'm using, and labeler token, which, So it's just a key value storage, and it's encrypted, the name of the key and the value of the key. That's it. I don't know if you have any questions about this section. Secret management, pushing to. So the secret management is at repo level now, and we're working on putting it like at the organization level. Yep. All right. Awesome.
Repo level secrets layer, or everything will be on the organization?
Yeah, you will have both. Yeah. If you want like the same secret across the whole organization, if it's only on the repo, you'll put it on the repo level.
And we have an API coming to set the secrets automatically as well. to make it easier.
Yep, absolutely. Thank you. So let's dive into the next and last step, which is how to cache dependencies. So usually when you build, you have dependencies, and here it's Maven dependencies in the Java world. So what we want to avoid doing, I can see that it takes me 16 seconds, and every time across the demo, I was going through Maven Central here, downloading from Central. So I'm going over the wire, maybe to the US or to any other location, I don't know, but it takes time, right? And I'm doing it once, so I have them locally, but I still go over the internet and fetch them again. So what I want to do is caching them. So what I'll do is use this open source action, which is called cache, and I need to supply a few arguments. So here is the path, so the data I want to cache. So I don't know if you're familiar with Maven, but basically when it downloads your dependencies, it stores them into /repository. And basically I want, so this data, all these dependencies, I want to attach them to a key so that I can just find them back in the cache. And here, so I find them, so runner.os, so based on the operating system I'm using, the Java version I'm using, and here I'm putting the hash files of the pom.xml. So basically pom.xml defines the set of dependencies that I'm downloading. So what I want is like, if the dependencies change, to invalidate the cache, and this key would be different.
Yeah. And here it looks a little bit complicated because we are doing a matrix build with several combination for each environment. But you know, a lot of people are using just one environment, one version of Java, and so that would be a lot simpler as well. But yeah, we try to make it more complicated to what we're usually doing.
So you will look smart. You know? When it's complex, you look smart. It's nice. And then we have the restore keys. So basically, when I have a cache miss, what is the best guess and what is the closest data? And here we can see that we just removed the hash files of pom.xml, so that I can find like the closest data possible, basically. And if we look now, so after caching the dependencies here, the test and package, we divided by two. The execution of this step. It was 16 seconds. And I'm not going to Maven Central because I didn't change my pom.xml, which is what I wanted basically.
And that's pretty important because so you have, like, if you have an open source project, you get 3 minutes to compile and to build. So there is a lot of free tiers that are offered by GitHub Actions, so you can use it for free. But if you are doing a lot and lots of builds, you might, first of all, it's annoying to have to wait long to get the build results, but also you might, go above the thresholds, and then you might need to have to pay for something that you could avoid. So it's a good idea if you can to avoid that. Yeah.
Absolutely. So I think the demo is over. So. As a sum up, basically, I would say that the pros of this is like the fact that it's integrated into GitHub and the fact that it's on the cloud, and the open source actions, which enables us to just we saw that, for example, for the caching dependencies or for saving the leverage what other people did, and which has been the strength of GitHub from the beginning, basically. And bringing that to the CI/CD space, it's really exciting. This product is evolving, and a lot of investment is put to it, so just stay tuned. And I think a lot of exciting stuff is coming. I don't know if you have anything to add.
Can we go back on the marketplace page?
Let's go.
Because there were some questions that were interesting about multi-cloud. Yes, marketplace, and so you get the filter here by actions. Then can you type AWS, for instance?
100%.
All right, so I think they're not listed. Well, the official AWS actions. Well, first of all, what we here see, you get the AWS update S3 action. So that's one way of getting, uploading things somewhere.
I have an idea. If we create a new, it will be suggestion. If we create a new workflow from here, it will
Yeah,
be the
it's
suggestion.
just sometimes there's too many things over there, so we cannot find exactly the one we're looking, because what can you just Google that? Maybe GitHub Actions, AWS, or something else. Probably we're going to stumble upon that. Yeah, there you go. That should be that one. Yes. Yeah. No. Go back. You had the link. Go back. Scroll down. Yes. Okay.
This one?
Yeah, this one. So that's the. So as you see, the great thing with GitHub Actions is we bring in the same philosophy that what you've seen in the open source world for many years. So people are doing it for us. We don't have to make actions to integrate with AWS. We don't have to make actions to integrate with Google Cloud. We made something that people can leverage and create their own actions. So here you see the AWS team creating actions, allowing you to deploy to AWS. Same thing for Google. Google created the actions to do that. And what we want is to have all the different vendors in the open source world or in the DevOps world or wherever to create their own actions. So you will find Terraform actions as well, created by HashiCorp. So they are bringing you the wrapper to their ecosystem that you can plug directly into GitHub. So that's a great way, and that's the best thing, right? You don't have to do it. We don't have to do it. They are specialized. They know what they're doing, and they're doing it for us.
And you don't have to maintain it, and
Yeah.
that is as well crucial.
But yeah, and that's a very good point. So if you can go back to the YAML file, because that's something I think we didn't really show. We look at the source file directly. Let's look at the WAR file if we can.
No.
That would go directly into the code, maybe.
Let's go to
In the .github. Yeah. Take the last one.
Then
Okay.
To .github workflows.
Yeah. Stop here. So one thing we haven't seen is you can have multiple pipelines. You can have multiple workflow in your repository. So and each of them can listen to different events. So you don't have to put everything with ifs in one single file. You can have many of them, and some listening to the same exact thing. If we look at one of them.
That one, since we didn't open
Any of them, yeah. So here you see so that syntax here is very important, because what we're saying is that we're going to look into the organization. There is a repo called checkout, and we're going to use the v1. So there is a git tag that specifies the exact version that you want to use. And here, for instance, it's the Azure organization. There's an actions repo. Within that actions repo, there is a login folder, and within that login folder, but we tie to master, which means here, if they are changing the code of the actions, you are executing a new piece of code, right? So moving forward, you're going to have to be a little bit vigilant about that, because you're giving that actions your secrets, right? You're giving them access to some stuff. So the great thing is they are open source, so you can look at them. It's kind of useless to look at them if they can change afterwards, right? Without notice. So here, one best practice would be to put a SHA-1. So you say exactly which commit you want to execute. Yes, it's a trusted one, because it could be also in a private repo in your organization, and then it's trusted. Then you could run the latest version on master. But if you're using a public one from somebody you don't know, then it's safer to use a SHA-1. If it's a vendor, if it's AWS, can they be trusted? I don't know. Well, if you trust them, you can do that. But yeah, just be mindful of that. It's one of the things that we need to be careful about. But yep.
This action checkout version 1.
Yeah.
Who provides that?
So the actions organization, it's us. Our actions, it's us. Yeah.
So it's here basically. If I go to github.com here.
Yeah. /actions.
/actions here. So this is the repository where
the organization. Yeah.
The organization. Sorry. And then
all these are actions that we have developed.
And if I find the checkout here it is. And you can write your own actions as well.
Yeah.
So you can have your own, like, within the company, you have like an organization like actions, and you can just run all your own actions, and you provide them to the rest of the companies. That is standardized, and you can manage the actions for the whole company if you're working for a big corporation, for example.
There are two ways to provide actions. You can provide a Docker file. So the implementation of your actions could be within a Docker, could be JavaScript based. So I mean, either you use JS or TypeScript, doesn't matter. But we have like a node runtime that will execute that action as well. So you can create your own and publish it directly on GitHub. I mean, it could be, if it's a public repository, it's available to everybody basically. And you can also ask to be listed in the marketplace if you want. Yep.
The syntax is very similar to Ansible. If I have an already existing task in Ansible, can I use it in GitHub Actions?
Maybe there's an action for it.
I install Ansible, for example, as an action, and execute a YAML file.
Well, if you look into the marketplace, you will find, I mean, the Ansible action, because, I mean, we don't, like,
Run playbook.
I want to execute an already existing playbook as an action, but I don't want to modify the
So then you can use the command line to execute the playbook. I mean, the run playbook CLI.
So I don't have to rewrite the entire pipeline. It's already written in Ansible, but I want to execute as a...
Yeah, like I think I have. Did I have an example in that?
In the end, it's just a Docker container. So you can anything. So as long as you have this environment, you have the command line as if you were just docker exec-it and then ping into the container. So it just works.
Like basically, yeah, you commit the playbook in your repo and you just run it locally.
Yeah. There's no reason it doesn't work.
I am surprised about, like, I am thinking the structure that you have to publish. What is the technical pool of what do you do? Because if all of us we are spinning containers, VMs, and we are doing caching, so how do you keep everything up and running? Because what you are saying is, like, if I have my Maven and my caching, I have a VM that is going to be sitting there waiting that the caching is going to be there. What do you do to recycle or to keep everything? Because I am thinking.
Trust us, it works. Honestly, I don't have the details. Maybe you do have.
No, exactly. But I mean, we keep the cache somewhere. I mean, the VM doesn't stay up and wait for you to come back. I mean, when your build is finished, then the VM is totally recycled. But we've stored that somewhere in the storage, and that we can restore later.
So that means that you have a storage where you are placing our files from the builds somewhere, and then you are attaching that with the VM. So internally, what's happening if there are some mistakes attaching files of other programs?
You mean for the caching part of things, it's caching, right? So it should be, the use case is really for technical files that you're going to need to use again for the next build.
I am surprised because it's too many people, so maybe you are keeping that machine for a week or 2 days or a month, I don't know, but it's, if that machine needs to be ready because it's my caching and I am going to request to business to make the build. So, and if I am in the free account, that means that you need to have a VM waiting for me to do the build, or even mounting a VM that is not in my caching folder. So, if you mention 3 minutes, everyone is doing the caching, that means like...
Well, we still provide that even for free. I mean, we manage that. So the cache is attached to your account. I mean, or to your organization account, or wherever you are executing the pipeline. And I mean, it's part of our job to make sure that we don't mix everybody's cache.
And we can name it. Yeah.
It's an investment on our side, obviously. It's costing money, but that's like the repos we've been hosting on GitHub.com for the past 12 years. It's costing us money as well. But
you know how many repo you have. You know what is the limit for each repo, and you can just do the dimensioning like this, basically.
So I mean, as long as you're not exceeding the free tiers, I mean, you're free to use our solution to the extent of what we provide.
You had another question.
Do you have any kind of mechanism to interact
with the workflow during the, on the execution time. For example, you pass all the tests, and after that you have to press a button to deploy, for example, to avoid the continuous deployment in production or everything.
We don't have any manual interactions built in yet. It's things we are thinking about, but it's not there yet. I'm not a big fan of manual interactions anymore.
Me neither.
I have a couple of questions. I don't know if right now it is possible to build an actual pipeline, running several builds or jobs in parallel, then after all of them are being done, execute another one using resources from the previous one.
Yeah, so you can have dependencies between jobs. So you can say this job depends on this one, this one, and this one, and then basically you have, whenever all this finishes, I want to execute that one. This is possible.
Dynamic jobs for this. Within one job, I read a file, and then depending on the content of that file, I need to start several jobs or not.
That's a good question.
So that would be possible within the context of one pipeline.
One workflow.
One workflow, yeah. So you could do that, but you could not at the end of one workflow trigger another workflow. Like, you cannot chain workflows. It has to be within the context of one workflow. For jobs and you can set some environment variables, for instance, and these environment variables could be an if to start and another thing.
Once the job is started, running or not command based on an environment variable. I mean that I need to read a file and start jobs. I don't know how many jobs I'm going to start. Maybe it's 100, maybe it's just two jobs. That kind of dynamic allocation of jobs.
I don't think that's possible.
Jobs directly to the actions.
But prevent people from shooting us in the foot, because that's us at the end of the day who needs to run that.
Could we have human, no? Which is something that is creating the profile and doing the publish and injecting the changes, and then another account or something like that. You can always go out to Travis and then come to GitHub.
No, but not because we look when you're committing a workflow file, so that YAML file, or you're making a change, so it's a git commit, right? But we're looking at what kind of authentication is being used. So is that an SSH key? Is it a personal access token? What kind of personal access tokens? Like, is it coming from an OAuth app, or is it coming from? We have some cleverness behind the scene to prevent some weird use cases that we don't want to deal with.
One thing is, we haven't seen any job running Windows machine. And
yeah, there was.
My question is, what application that a Windows machine has? Because in my use case, I'm very interested in C++ applications. So I would love to have a virtual image or whatever you use for Windows with Visual Studio installed. So I don't know if that's...
yeah, you can go for it.
What, can you log me in?
Yeah, of course. So you want Visual Studio at which place, sorry, so that I can understand the question?
I want a Windows image or virtual machine or whatever you use for Windows.
Virtual machine,
Visual Studio, in order to build C++ applications.
Ah, to build it. Okay, cool.
Oh, there you go.
Maybe there is. If not, you might have an action which installs it. Anyway, like I set up JDK, you might. If it's not by default.
So that's what's listed over there. So you got.
It's a VM, yeah.
Yeah, that's a VM. It's a real Windows machine, yeah.
Yes.
If my application needs an X server or to use the GPU, is it supported, or the VMs don't have GPUs or X servers? If I want to test graphical user interface application, for example, or running some CUDA application?
I don't know.
That's a good question. I haven't tried it. If you run that on Windows, I mean, you probably have a Windows context over there. I would not think that the Linux one has that. Let's see. Come on, to see.
Do you want visual interface for what?
For example, a huge application, graphical user interface or whatever.
Yeah.
Or an application that requires to compile it against to that library.
Yes, makes sense.
Yeah, we will need to double check that. But I mean, what you can do at the end of the day, you can also one of your machines and use that. So you can run your own agent. And if you're running your own agent, there is no more sense of billing. So, I mean, because you pay for the infrastructure yourself, so you can do whatever you want now.
Yeah, that's the question.
Yeah, you pay for it. Yeah, I don't know. I honestly don't know about that. That's a good question. We have to double check that.
Yes?
I suppose that in the enterprise you install yourself in your infra, but using the SaaS solution, it's possible to connect to VPC, for example, AWS or whatever.
To do what? Like how?
Yeah, for example, to trigger some kind of internal thing in your infrastructure.
You can via HTTP if you want. You can basically it's just like command lines. So whatever, if you want to have a program which you have the complete freedom. Like it's like just imagine as if you have a shell. If from a shell you can access your VPC, you can do it from this action. If you can't via your shell, you wouldn't be able to do it. Basically, that really comes down to just having a machine which have instructions basically.
Yeah, we are not restricting on our side any output, but then on your side, if you have a BC to our IP range and whitelist them, if you want a GitHub Actions run on our cloud to connect back to you, but it's just a network configuration.
All right.
I have an issue.
Yeah.
Maybe it's related to what we talked before about restrictions of which actions can trigger other actions. I use GitHub pages
Okay.
to publish my blog.
Mm-hmm.
So if I try to run an action that updates the HTML of the static site, pages won't be updated.
Yeah.
So I have to use another repo and then push the changes to the other repo, and then the changes that other repo has a GitHub Actions workflow that will cross-push the other repo. This is an open issue.
That's exactly because you are using the GitHub token environment variable to do the push, and that's like GitHub pages doesn't want automated processes to do the update. So there is a limitation of there because of the kind of tokens. So the solution to that is to create a personal access token, the generated GitHub token. You put that personal access token as a secret in your repo, and you use that, and you push doing that. Well, it's locked, but I've done it, so I can show you how it works. Yeah, just don't remember my repo where I'm doing that. So
you just found an excuse. It's locking. Sorry.
Oh yeah. So yeah. So well, first of all, that's what I was telling you about. Like, if you want to use a SHA-1 specifically, it's an open source repo, so you'll be able to find it. And what I do here, I haven't worked on that one for quite a while now, so I don't remember exactly everything I've done. So I'm doing the Git commit. Yeah, so that was a different repository, but okay, it's not that one. It's another one. But yeah, I mean, anyway, if you do that, like as I say, it will work. I have that somewhere else. But this repo, I mean, if you want to play with actions, I mean, it's still work in progress over there, but I created a cheat sheet, so you can get it in PDF. So action. So it's a GitHub cheat sheet generated with a GitHub action, and it's based on Markdown and ASCII Doctor. So I just can change the text through a pull request, push it, and it generates a new version of the cheat sheet. So I think it's pretty cool.
And any plugin for this particular code or something? Is there any plugin?
For GitHub Actions?
Is that highlighting or?
It's YAML.
There is one. I mean, you get syntax highlighting when you are changing. Yeah.
I see what you mean.
So if you no, that's not this one.
Tu peux dézoomer un peu.
Here, the file. So here you will have syntax highlighting directly in this environment. So it will do that. Yeah, you have.
Yeah.
So if I'm, why don't you have a French keyboard?
Because I'm
there
cool.
you go. So see, I mean, it's showing up stuff. There you are. So you have that right away. I don't think we have that in Visual Studio Code yet, but yeah, so it's kind of a cool idea as well. So yeah.
Do it.
But yeah, we have that. Yeah, do it.
Just kidding. Thank you very much for being here. And
no more questions? Yep.